Take a look at the water in your bottle, the invisible air you are breathing right now, and the solid metal chassis of your smartphone. They look and behave entirely differently, but dive deep inside that metal, or the water, or the air, and you hit the exact same foundation. They are all constructed entirely from matter. Matter is built from atoms, the fundamental microscopic units that construct everything in the universe. Curious, but how do the exact same invisible building blocks create a wet liquid that extinguishes a fire while also forming a hard, conductive solid? The answer lies in how these atoms organize themselves. Categorizing matter into elements, compounds, and mixtures allows us to predict exactly how a material will respond to heat, pressure, or a chemical reaction. We start with the simplest ingredients, elements. An element is a pure substance constructed from only one specific type of atom. There are about 118 known elements. If you have a block of pure iron, a tank of oxygen, or a lump of carbon, every single atom inside is identical. Watch what happens when different elements chemically bond. Two identical hydrogen atoms snap together with one distinct oxygen atom, forming a compound, a water molecule. Though both are highly flammable gases, their bonded liquid form smothers a flame. Compounds follow a strict baking recipe. They require an exact fixed ratio of atomic ingredients to successfully form a new substance. 2 hydrogens to 1 oxygen, always. This chemical bonding permanently erases the original traits of the individual elements, forging the complex, stable materials required for life. If a compound is a strict recipe, a mixture is a physical salad. In a mixture, different substances occupy the same physical space, but they do not chemically bond. Because no chemical bonds are formed, the components keep their original properties. When you stir sugar into water, the sugar crystals disappear from sight, but the water still tastes sweet. The sugar is still sugar. You can also freely adjust the ratio of ingredients. Add a little sugar, add a lot. It remains sugar-water. The fundamental identity of the substances stays exactly the same. This illustration shows the 2 types of mixtures. On the left is a stainless steel spoon, perfectly uniform throughout. That's a homogeneous mixture. On the right is a chaotic pile of sand and pebbles, with visibly distinct separate parts. That is a heterogeneous mixture. Think of a glass of cloudy lemonade. Undissolved salts and melting ice float and settle inside the glass, creating visibly distinct, non-uniform layers. It is easy to look at a clear liquid solution like sugar water or a solid alloy like stainless steel and assume they are pure compounds. They aren't. They are mixtures because their individual atoms never chemically fuse. This lack of chemical bonding means we can temporarily blend materials together to get specific physical traits without permanently altering their atomic identities. Because mixtures are only physically blended, we can use mechanical tricks to pull them back apart. In filtration, a mesh traps large solid particles while liquid flows through. Applying heat causes evaporation, forcing liquid to escape as gas, leaving solid crystals behind. For mixed liquids, distillation vaporizes one first, condensing it back into a pure liquid. But remember, these physical separation methods only work on mixtures. You can boil water all day, but it will never break apart the chemically bonded hydrogen and oxygen of a compound. Our ability to physically undo these mixes is the foundational mechanism we use to purify the water we drink and refine the natural resources required for human survival. Apply these atomic rules to the scale of the Earth itself, and you get minerals. Minerals are naturally occurring solids with fixed chemical compositions. They exist either as pure native elements, like a vein of solid copper, or as complex compounds, like crystalline quartz. When these mineral deposits are highly concentrated, we call them ores. We mine and extract these ores to drive technological progress. By mixing cement, sand, and water together, we engineer a highly durable, heterogeneous mixture, modern concrete. By forging iron, chromium, and carbon, we engineer a perfectly uniform, homogeneous mixture, the rust-proof stainless steel that frames our cities. This flowchart shows the definitive hierarchy. Everything is matter. Matter is built from pure elements. Elements chemically bond into strict compounds, and all of these physically blend to create mixtures.
The next time you look at a glass of cloudy lemonade, try to trace the path back to its pure atomic ingredients. By distinguishing a chemical bond from a physical blend, we gain the ability to dismantle the complex world around us and reassemble it into the technologies of the future.